Hi everyone, myself Kushal, and I would like to explain about the perks of using the FP growth strategy. As my teammates explained about a priori and the FP growth algorithm, and what is the reason of to we choosing the FP growth strategy. Um, I would like to continue about the same topic, and we'll be comparing and will give you the comparative study of both the algorithms performed on some of the existing data sets. Now let's go. Let's see on what parameters the FP growth strategy is actually better. So one of the first parameter is the database scans. In the FP growth strategy, the number of the database scans happen for the whole process is only two times. One is to find the number build a tree, and the other one is to actually build a solution. But when you go to the a priori algorithm, it actually creates the candidate sets. For creating the candidate sets, it actually goes to database number of transactions plus one number of times. And the second parameter is the memory utilization. A priori algorithm uses a lot of memory because it has to create the candidate sets. But if the FP growth algorithm, we actually use a tree data structure where we actually store all the products or the items in the dataset in a tree structured format so that it actually utilizes very less memory. And the third parameter is the execution time. If you look at the a priori execution time, we know that the a priori algorithm execution time is exponential with the transactions we have. But if the FP growth algorithm is linear with the number of transactions of the dataset. And now we will see what are the results, what are the experimental results that we got by performing, by testing these algorithms, to both the algorithms a priori and the FP growth algorithm on two datasets. The first dataset that we use here is supermarket dataset, which has 4,627 transactions and 217 uniquely distributed attributes in it. And the second dataset is the mushroom dataset, which has 8,124 total transactions and 22 unique number of attributes in it. These datasets have been taken from UCA repository of machine learning dataset. Yeah, now we'll see the comparison between the execution time and the number of the transactions. How the execution time is actually being varied on the number of transaction increases. We will test this thing both on a priori algorithm and FP growth algorithm. When we see the graph represented here for the mushroom dataset, which has a support of 0.1, as the number of transactions is growing, the a priori algorithm execution time is actually exponential till the end, till end. But the FP growth algorithm is kind of exponential in the beginning, but when it reaches to the certain number of transactions, it started being little bit linear. But on the supermarket data set with the same support level of 0.1, when the number of the transactions is actually increasing, the FP growth algorithm execution time is linear here. But if you see the same structure for the same structure for the a priori algorithm, you can see the graph has been moving up exponentially. It is growing when the transactions are actually increasing. And now let's see another parameter difference with the execution time and the support levels that we have taken. So when we see the mushroom data set, which we actually took of 2000 transactions, when you look at the graph, the both a priori and the FP growth, then the support level is actually increasing. Both the a priori algorithm and the FP growth algorithm execution time is actually getting reduced. You can see the FP growth algorithm has performed really better when you compare with the a priori. In the FP growth, if we are moving to the zero execution time, then we have the more support level. But at every point, at every point of the support, you can see the both algorithms were differed with the execution time at every point. Now let's see another data set. Supermarket data set, if we actually do for the only 2,000 transactions, out of it, what we can observe is here, as the number of the support levels is actually going increased, the execution time is coming down on the algorithm, both the algorithms. But still, here also we can see that there is a huge difference between the execution times at every level between both the algorithms. So from all these things, we can actually see that our FP growth algorithm is actually performing really better compared to a priori algorithm. This is actually, from this we can say that the FP growth is actually better from the a priori. Thank you.